first set man into space, we have had to figure out how to provide the basics to keep astronauts alive. Those basics include food, water, and air. On the International Space Station, systems have been developed called the Environmental Control and Life Support System. It's a life support system that provides and controls atmospheric pressure, fire detection and suppression, oxygen levels, waste management, and water supply. The highest priority for the system is the atmosphere, but the system also collects, processes, and stores waste and water, produced and used by the crew, a process that recycles fluid from the sink, shower, toilets, and condensation from the air. It is easy to imagine that systems similar to those on the space station would be used for future Mars missions. Our trip to Mars and back with time on the surface will require each of our 4 crew members to consume 3,600 pounds of food with 900 pounds of packaging. That is 14,400 pounds of food for the crew to make the trip, and 3,600 pounds of packaging. The dream to go to Mars has been around forever, and has been the theme for movies, books, and Disney park rides. There are many designs and planning for what type of rocket will take us to Mars. Because there is gravity on the surface of Mars, they will be able to grow food in biospheres and greenhouses. In 2013, an experiment took place in Hawaii with 6 scientists called the Hawaii Space Exploration Analog and Simulation. For 118 days, the scientists used only the food they brought and tried to live as if they were on Mars. NASA has been testing food and making recipes since 1960s in their Advanced Food Technological Kitchen. Most foods can be freeze-dried to allow for preparations in space. That means that the sky is the limit for food, and I am sure that some candy can be taken to satisfy a sweet tooth too. On Mars, water can be extracted from the soil. It lies below the surface. Since Mars has gravity, water can be used the exact same way on Earth. Each astronaut will be able to use about 50 liters of water per day. The water will be recycled, which takes much less energy than extracted it from the Martian soil. Only water that cannot be recycled will be replaced by water extracted from the soil. Oxygen can be produced by splitting water into its parts, hydrogen and oxygen. The oxygen will be used to provide a breathable atmosphere in the living unit, and a portion will be stored in reserve for conditions when there is less power available, for example at night and during dust storms. Waste in space and on a planet needs to be treated with care. A system developed at Cornell University with orbital technology dries out trash and waste, making it inert, and allows the water in it to be reused.